Hello everyone, welcome to another episode of Scholarvision. I'm Saad Ahmad, Chief Cardiology Fellow for the Division of Cardiovascular Health and Diseases, University of Cincinnati College of Medicine. My guest today is Dr. Jack Rubinstein, Director of Clinician Scientist Training Program and Assistant Professor of Medicine, University of Cincinnati College of Medicine. Welcome to our program, Dr. Rubinstein.
Good to be here.
In this challenging era, when research fundings are tougher to secure, you represent the trifecta of a teacher, clinician, and a scientist. Your research, as we know, is moving from bench to bedside. Can you please tell us a little bit about your research and also elaborate on the importance of clinical collaboration for the progress of science?
Sure, absolutely. So I've been working at University of Cincinnati for about 5 years now, and we have a wet lab in which we've made some really interesting discoveries and really interesting findings about how the heart functions and how we can make it function better, particularly for patients that have heart failure, in which their pump doesn't work very well. So we've been working on this for about 5 years now, and we found molecules, we found targets, we found drugs, medications that have been used for other things, but we're trying to repurpose them for patients with heart failure. So in the first few years, what we did is we found how these drugs work, and we found how they work with the targets, with the heart, in the heart cells, and then we moved on to small animals. And we worked on small animals, and we proved that what we thought was working in the cells to make the cells work better, the heart cells work better, was actually working the same way with the mice. So that was really interesting for us. We had a lot of support from the clinicians and the scientists within UC, and we were able to secure funding to take it to the next level, which was in larger animals. So we started with the cells, we moved on to small animals, and then we moved on to larger animals, every step of the way confirming and knowing more about how the drug works and how the target that drug was hitting, how that is working, and if it's affecting, and how it's affecting the way that the heart can function. So in the last 6 months to a year, we've been in a really good situation with funding from the American Heart Association, local funding as well, and some national funding in which we were able to take these findings to the bedside. So to do this is very difficult to do. Usually these kind of findings takes many, many years, if not decades, to bring from the molecule through the animal models to the bedside. But since we had a lot of support from the scientific and the clinical community here at UC, we were able to do this with relative speed, 4 or 5 years being quick in the research area. I know it sounds like a lot, but it goes by really fast when you're trying to get all the steps lined up. And we've been working with a heart failure center here with Dr. Dunlap and her team, and we've been recruiting patients with different types of heart failure, and we've been testing our drugs. And this has all been IRB approved. IRB is the Institutional Review Board, so all of this has gone through many, many levels of safety checks to make sure that we're not hurting anybody, and we have not hurt absolutely anybody. Not only that, we've made patients feel better. So we're very, very excited about where we're going with this. We've got our first set of preliminary data in the last few weeks, and we're looking forward to increasing the population size so we can do larger studies and really see if the drug can not only make patients feel better, but potentially help them live longer with heart failure. So the scientific and the clinical community at UC have been incredibly helpful in getting us from point A to point B, which is from a molecule to a bedside.
Exciting work. Keeping our viewers in mind, which include aspiring research clinicians, at what stage of your training did you realize you would pursue an academic career?
Yeah, that's an excellent question. So people like to think that all physicians are researchers, but I found that not to be the case. Some physicians are really, really just made to be great physicians, which is spectacular. They go see patients, they get really, really good at what they do. But some of us along the way, we get sort of the bug. We call it the bug. It's almost like an infection, because once you get the bug, you really don't ever let it go. And this bug is sort of like questioning why we do what we do and how we got to where we are in medicine. So we read up a little bit about the history, and we sort of start doubting a little bit about certain things, how they work. And then if you're lucky like me, you run across several mentors along the way that can guide your interest in research towards something that can actually help people. So I don't think there's a good set place where people should become researchers. Some people get the bug as early as high school. So we have some high school guys and girls in our lab that are working, and they're interested in, of course, their knowledge base is not the same as a physician, but they're interested and they're working on it, and they get the bug early on. We also have MD PhD, so these are people that in college really recognize that they want to do a research and a physician career, so they get both an MD and a PhD. So these are really, really hardcore, very, very smart, very hardworking young people that get both sides. But not everybody has to know early on in their life that they want to do research. I've seen a lot of residents and fellows, as they progress through their medical education, get the bug and then jump out and leave a little bit of clinical work for them, but also a lot of work for research, and then try to find this balance throughout their careers, which is not easy, but I think is very, very, very useful, because people that dedicate their life to science may not have the clinical acumen and the clarity of mind to see, oh, I could do this or I could learn that when you see a patient, right? So so the short answer to your question is there's no good time to get it.
Right.
Any time is a good time. There are many opportunities out in the world, in the United States, and particularly in Cincinnati, where somebody that gets the bug can actually go and start doing research. For me, it was pretty early on, but again, different people get the bug at different times.
Right. Starting off, at an early stage in your career with research, where do you foresee the focus of cardiovascular research in the next decade?
Excellent. So I was just talking with a guy at the dealership, of all places, and he had a heart attack, and he was asking me exactly the same question. So 5-10 minutes ago, we were having that same conversation, and I gave him a baseball analogy. So when you turn on the TV or the latest news, it seems like there's always like this new thing that's going to revolutionize medicine, revolutionize cardiology. And in my 10, 15, 20 years that I've been between medical school and now, I don't think I've seen very many home runs. I've seen a lot of very, very strong singles, strong doubles, in which we make incremental gains. We make small improvements to the healthcare. We change the dose of a medicine. We give one medicine instead of the other medicine. And we slowly but surely improve the outcomes. We've also been focusing a lot on prevention. So the more we prevent, the more people exercise, the longer they start living, the better life they live. So I think we're making a series of incremental gains, a series of singles and doubles that will really get us to a better outcome. I don't foresee in the near future any great home runs that are going to change the way we manage our patients. Our people are still going to have heart attacks, and we're still going to open up their arteries, and we're still going to give them medicines to protect their heart and to make their heart function better. We're just trying to find slightly better ways in which we make small incremental gains into a point that I don't think we'll ever cure heart disease, but until we make it as manageable as humanly possible. We're not there yet, but I keep believing in this strong singles and doubles that can get us to a better place.
Perfect. Thank you very much for talking with us,
My
Dr.
pleasure.
Rubinstein.
Thanks for having me. Appreciate it.
I would like to end with a quote by noted mathematician Charles Sanders Peirce. "It is not knowing, but the love of learning that characterizes the scientific man." Till next time, keep on asking questions. This is Dr. Saad Ahmad. Thank you again for joining us on Scholarvision.